So good morning, students. Today the topic is graph coloring problem, and that we did previous. We started off with backtracking, and we did the Queen's problem. In a similar manner, we will do this graph coloring problem. Now, what is the graph coloring problem? Graph coloring problem was faced by the English people in olden days. When they devised the map for world, so they wanted minimum colors to be painted with the regions to be painted with minimum colors. But now, how they will decide what are the minimum number of colors which are required? So in earlier days, the printer was not so efficient. They will be coloring the graph or the map with one color at a time. Suppose एक जो map है उसके अंदर 20 colors होने चाहिए. So 20 times that paper has to be passed through the printer. Fine. So that is there. So in order that means उसका फिर खर्चा बढ़ जाएगा. खर्चा क्यों बढ़ेगा? Because number of times the printer will go, तो उतनी बार electricity लगेगी, उतनी बार आपके colors लगेंगे. So they want to reduce the cost, and they wanted to find the method what are the minimum number of colors by which we can differentiate between the different regions in the map, and we can also color that. Fine. So in order to do that, this problem was devised, which was known as graph coloring problem, and I'll let you know how this was used in maps. Later on, we'll come to this solution. Now, graph coloring problem says, see, you will be given an undirected graph. This you know when the directions are not given in a graph, it is an undirected graph. Fine. So we have how many vertices in this graph? 5 vertices, right? And no to graph coloring problem says you will be given some number of colors. You'll be given some colors like RGB. We have been given 3 colors, and we have to see whether we are able to paint these 5 nodes with using these RGB colors. Means 3 colors we can paint this graph or not. Right? So that is called M coloring decision. M coloring decision you can say. Means we will be given 3 colors which are different, and we have to check whether we will be able to paint the graph using this RGB or not. If by using this M coloring decision, we have to answer whether it is yes or no. Means the number of colors will be given to us. We have to check whether we'll be able to paint this graph with these number of colors which we are given. If yes, then okay. If no, then it's also okay. We can write, we can paint or we cannot paint. Fine. And this particular problem is called M coloring decision problem. Now, next is what are the various minimum number of colors? What are the minimum number of colors required to paint a particular graph? This is called K coloring or chromatic number. This is called K coloring or chromatic number. Means the minimum number of colors you have to find. What are the minimum number of colors required? Fine. Now, what is the condition for paint this graph? That is the 2 vertices which have an edge between them. Means though the vertices which are directly connected. The vertices which are directly connected should not have same color. That is, if the vertex 4 and 3 are directly connected, they should not have same color. Fine. Similarly, 1 and 2 are directly connected, they should not have same color, they should have different color. So the graph is to be painted in such a manner that the 2 directly connected vertices should not have a same color. The vertex should not have a same color. Is that clear? Please raise your hands if it is clear. I want to see number of hands, and we can start. We have to see in a graph, if there is a direct edge between the 2 vertices, they should not have the same color. In the similar manner, as we have formed the state solution space for N-Queen problem, in the similar manner we can make the state space diagram for this graph coloring problem. Let's see how we will make it. First of all, let's find its solution randomly. Then we will see how to draw the state space line. See, if we are painting first node, this path is getting outside. Let me end. Okay. Let's suppose if we are painting with this red, first node is painted with red. Can we paint two number node with red? No, because our condition says that no two vertices which have a direct edge between them, they should be painted with same color. So we will be painting this with green. Now, with which color we can paint node number 3? Because we cannot paint it green because 2 and 3 have a edge between that, and we can paint it with red because we don't have a direct edge between 1 and 3. If it would be like this, then we have to take the third color, that is blue. If it would be like this, then we have to take the different color. Fine. Now see, this is the RGB. I have made a edge. If I remove this edge, then we can paint this node number 3 with the red color. See, if I remove this edge, if I have, oh sorry, this way. If I have moved this edge, now I can paint this with red color because there is no direct edge between 1 and 3. Now, with which color I should paint? I should paint color for node 4. See, there is an edge between 3 and 4. So we cannot paint it red, but we can paint it with green because we don't have direct edge between 2 and 4. Now see, 1 is connected to 5 and 2 is, 5 is also connected to 4. Now it's a turn of 5 number vertex. 1 is connected to 5 and 5 is connected to 4. What is the color of one node? That is red. Here it is, which color? Green. So neither we can paint vertex 5 with red, or nor we can paint it with vertex, nor we can paint vertex 5 with green color. So we have third option, that is blue. That means minimum colors which are required to paint this graph are 3. Minimum number of colors which are required to paint this graph are 3. Fine. So next thing, you can, so this is one solution. This is node number 1, 2, 3, 4 and 5. First node will have red color, second node will have green color, third node will have red color, fourth node will have green color, 5 node will have blue color. Can we try some other solution? Because in backtracking we need all the possible solutions. So let's do it with different combinations. So let's do it. See, if I give it green color, now I can paint blue with the red. We can paint 3 with the green. We can paint 4 with the red. Now here I can neither paint 5 with green or with red. Then we will take the third color, that is blue. Okay. So this is another solution. If I say this will form another solution, which is the solution? That is green, red, then green, then blue. Okay. Or we can take another solution like this. We have started from green. If I put blue color here, then what? What should I do? Green, then again blue, again I can do it with red because red is a different color. Fine. So S3 would be green, blue, then you have red. Or we can S4 as red, blue, and then you can have vertex as green. Or next, we can have blue color at the node 1, then you can have red, then you can have blue, then you can have red, then you can have green. So S5 would be blue, red, blue, red, then you have green, or you can have like this.
Oh, excuse me, ma'am.
Yes,
Ma'am, Parth is waiting to. Parth
Parth,
is.
I have allowed him.
There is some
Parth
problem.
is, I have allowed him.
Maybe there is problem with his connectivity.
Okay, I have also allowed Navneet.
Thank you very much, ma'am.
Okay. So we have painted one node with blue, then two node with green, three node with blue, four node with red, and five with. Sorry, here it should not be. So this would be S6, blue, green, then red. Fine. So in this way, you can find the number of possibilities. If it is clear, please raise your hand. If it is clear, then please raise your hand. So M coloring means it will tell us whether we are given three colors. Suppose if we are given four colors, then is it possible to paint this graph? If I have been given four colors, is it possible to paint this graph? Please answer yes or no. You can unmute yourself and tell me. Please unmute yourself and tell me whether we'll be able to paint this graph with RGBY. Yes or no? Anyone can unmute and tell me. Anyone. Narendra, Paras, please tell me whether we'll be able to paint this graph with four colors or not. Narendra, are you there or sleeping?
Can you let me in the meeting? I'm disconnecting from the phone. I've started in on my laptop.
Okay, I've allowed you.
Thank you, ma'am.
Narendra, are you there? Navjot, Nancy, nobody is replying. What happened today? Prince Agarwal, please unmute yourself and reply me. Please unmute yourself and reply me. Ritika, are you there? Ritika, please unmute yourself.
Yes,
Narendra,
ma'am.
will we be able to paint this
Yes, ma'am.
four colors?
Yes, ma'am.
Why?
Yes, ma'am.
Why?
Ma'am will be able to, but we want minimum number of colors.
We want that is a separate question. I have not asked you what is the minimum number of colors required. That we have found. The minimum number of colors required is three. But if we
Yes.
are given four colors, we have been given four colors. Will we be able to paint this graph? Yes or no? If yes, then why?
Maybe yes, ma'am.
It is yes, because if we are able to paint the graph with minimum number of colors, that is three, then definitely we will, if we have more number of colors, then we can also paint this graph. See, if I make this node as yellow, what is the problem in it? Is there any problem? No. So we will be able, minimum हमें तीन चाहिए, उसके ऊपर जितने मर्जी colors हो जाए हम उसको paint कर सकते हैं. That is your choice.
Okay, ma'am.
If you have been given more than five colors, then it's your choice which three or four colors you are going to pick from that particular set of colors. Okay, but you can paint. The answer is yes. Okay,
Okay, ma'am.
you can paint this graph because you have been given one more color to paint this graph. Fine, and you can easily paint that. Okay, there is no problem.
Okay,
But
ma'am.
when you are given more number of colors, then you have to pick up any color you want to paint the graph with, and that is your choice. Right? It is not necessary what is being given to you. You will be asked this thing only. If you are given one or two more colors than the required minimum number of colors, will we be able to paint the graph? The answer is yes. Okay. The answer is yes. Okay. Next, let's make the state space diagram for a particular that. So sometimes, see, I tell you one thing. There are two terms I just want to make it clear. One is M color optimization. Now what is M color optimization? What does optimization means? Yielding the minimum or maximum value. Here what we are yielding the minimum number of colors which are required to paint this graph. So that is called M coloring optimization problem. So you should not be get confused with this term. What is M coloring optimization problem? It is the number of colors which are required, minimum number of colors which are required to paint a given graph. Fine. Then you have M chromatic number. Decision, that is whatever the set of number is given to us, whether you will be able to paint that graph or no. So that is called M coloring decision. Fine. So these are the two things. Okay. And it is also known as chromatic number. Chromatic number is itself the minimum number of colors which are required to paint a graph. So let's make a, I'll reduce the size of this problem and we will make the state space diagram for this. Okay. So that both the things will be clear. Just hold on for making this diagram. So this is the undirected graph which is given to me, and I have been given three colors to paint this graph, R, G, and B. So let's start off with the making the state space tree, state space tree. Where we will start from? We will start from the beginning node, that is root node. So for x is equal to 1, for first color, first edge के लिए हम पहले इससे तीन केस हैं. For first number, we will be taking red color into the account. Am I audible? Please reply. Am I audible? Ritika, you please reply. Am I audible? Am I audible to all? Please reply.
Yes,
Yes,
ma'am.
ma'am.
Okay, thank you. Are you able to see the board?
Yes, ma'am.
Okay, fine. Fine, thank you. Okay. Now for first node, that is x is equal to 1, that is vertex number 1, the color can be red. We have to make all the choices. I will be making it one by one. Then for x is equal to 2, that is second node. First node को आपने color दे दिया red. Then we have three options for x is equal to 2. One is red, second is green, third is blue. Okay. So as my first node is red, we cannot paint x is equal to 2 with the red. Fine. I have been stopped by bounding function here because my bounding function says that I cannot give the color blue, I cannot give the color red to x is equal to 2 because my first node is painted with red color. See, if I give red color, can I give? No, because both the vertex will have the same color. So I cannot give it a red color. Fine. So next, now it is to be painted with either green or blue. Second node can be either painted with the green or blue. Let's move. If I painted green, now what about x is equal to 3? What about this node now? It can also have three options. I'll make it red, green, and blue. So this will be stopped because if I have painted it with green, I cannot paint 3 with green because it is a directly connected vertex between, directly connected edge between 2 and 3. So it will be stopped by bounding function. So I can paint it with red or blue. That is another option. So let's do it for first case, then we'll do it for second case. Okay. Now, so this is being stopped by bounding function. Now, what about fourth node? X is equal to 4. Again, we have 3 options: red, green, and blue. See, 1 is connected to 4, so we cannot give it red color, so it will be stopped by bounding function. Again, 3 is also having red, so we cannot give 3 or red.
Excuse me, ma'am.
Yes.
Ma'am Simran wants to join. Ma'am, please allow her.
Okay. See, your 1 and 3 are both with red color, so you can either give it green or blue color. So you can paint it with green color. So this is my one solution. Okay. So second solution would be red. First solution will be red, green, red, green. Second solution can be red, green, red, blue. Okay. So this is my second solution. Now let's come to this side. If I painted this node with blue color, now what would be the solution? Let's see, x is equal to 3 is blue, red, green, and blue. We cannot paint x is equal to 4 with blue because I have been stopped by bounding function here. But we can paint x is equal to 4. Here we can also do not do this because here one node is with the red color. So we can either give red or not. We can give blue to node number 4. So we can only give green color to node number 4. So solution 3 would be red, green, blue, green. Okay. We cannot give red color here. If we give red color here, then this will clash. Fine. And if we give blue color here, then this will clash. So only color left is green. Only color left is green. See, I again repeat, if I give it blue color, then I'll be stopped by bounding function because there is a direct edge between 4 and 3. Now, if I paint this with the red color, then I will be stopped by node number 1 because both of them are having a direct edge between 1 and 4 and they will be having red color and it will be clashing. So the only color left is green. Fine. Now we can make, this is one part. This is only from starting from 1 if we have opted for red color. Fine. Now you can make another side where you will be taking the first node as green. Fine. First node as green, or we can also backtrack. See, this we have done for node number 4. Now you can backtrack. That is, if you assign blue color to node number 2, if I put 2 blue as here, fine. Now what happens? Red, green, and blue. Blue will be stopped by bounding function. I'm just rubbing this because we are short of space here. Red we have done, blue, green we have done. Now let's come to blue part. Now if I painted node number 2 with the blue, now what happens? For 3 you can have red, green,
Excuse me,
or
ma'am.
yes,
Ma'am, please allow Rohit. He is waiting.
allow. So R, G, and B for the third node. Fine. So if it is blue here, now what happens? Can we give red color? Yes, we can give. We can give either green color. Both of them we can give, but we cannot give blue at node number 3. Fine, because blue and blue are going to be clashed. So let's suppose for the first case we will doing it with the red color. Fine. Now, what about x is equal to 4? 1 is red, okay, 3 is red, okay. Now we cannot paint 4 with red color. We cannot paint 4 with red color because I have been stopped by bounding function, but I can give it green or blue color. So my two solution would be S4 will be this way. Okay. Red, blue, red, green. S5, red, blue, red, blue. Okay. If I put blue here, then there is no problem. Fine. Or we can put red, blue, red, green. We can also do this. Either we can put blue or we can put green. Fine. So this is one of the problem which is being solved. So let's backtrack. If I put green color here, green color here. Now what would be the left option? See, I cannot paint this with red. I cannot paint this with green. So the only option left is blue. So we will try red, green, and blue. We cannot paint node number 4 with red because 1 is directly connected to 4. So that would be clash, and we cannot paint your 4 node with green because 3 has already green color. So we have to paint node number 4 with the blue color. Fine. So this is your state space diagram for one part. Similarly, you can make blue. Similarly, you can make green. That means you have to put, first of all, you have to put green color here. Then you can put blue color here, and vice versa, you can make the green. If you can make it, please raise your hands. If you can make, please raise your hands. Can you paint it for green? First node you have to take blue, then you have to take green, and so on. I'm not looking much of the hands. Kushpreet, Mridul, Nancy, Nazpreet. See, this is your home task. You have to give me the remaining solution. I've given you the 6 solutions here. You can form 6 plus 6 plus, I mean 18, 20 solutions would be there. You just give me the number of solutions. Okay? You have to provide me. Fine. So this is the graph coloring problem. Now I will tell you one thing more. Now how will you do it in a real map? See, I am making just a random any map. Fine. So okay. So this is a map which is any portion of any country which we have to color. So different regions will be marked as vertices. So this is R1, R2, R3, R4, and R5. Okay, fine. So you can make the this way. So this will be your graph. This would be a graph with vertex 1, V2, V3, V4, V5. Now, can you find the minimum number of colors which are required to paint these 5 vertices? Because we have done already with the 5 vertices. Yes or no? Suppose if I make another node here, R6. So let's do it this way. Can you draw the map now? Can you tell me what are the minimum number of colors which would be required? Please tell me yes or no. Unmute yourself and tell me. Narendra, are you there? Prabjot Singh, please unmute yourself and tell me. Anyone, if you are not getting it, then also tell me. Am I audible? Please apply this font.
Yes, ma'am.
Okay, fine.
Yes, ma'am.
Will you be able to now color this graph? Will you be able to find the minimum number of colors which are required to paint this graph? Yes or no? See, for 5 vertices we have done. How many colors are required? Minimum 3. Fine. And for 6 vertices, it may be 4. Okay. So you have to make the state space diagram and you have to tell what are the minimum number of colors which are required to paint such kind of graph. Okay. Yes or no? Please raise your hand if you are not able to answer me.
Ma'am, can you repeat once?
See, this is the map which is given to you on a screen, fine. And I have different regions R1, R2, R3, R4, R5, and R6, fine. And every region depicts the vertex of a graph, and there is a directly connected edge between two regions. So that is your edges between the vertices. You may assume it. Now, can you find the minimum number of colors which are required to paint this graph? I make it more clear. If it is not clear, I'll make it more clear once again. See, this is the map which is given to me. I have to paint this map with the minimum number. I have been given the problem to paint this graph with the minimum number of colors. Sorry. Just wait. Okay, so this is the different area graph. I can denote it with region 1, region 2, region 3, region 4, region 5, and region 6. So let us consider this as vertex 1, vertex 2, vertex 3, vertex 4, vertex 5, and vertex 6. So let's draw the edges between the two vertices. Now, can you make out from this graph? I'm again making it on the right hand side for your convenience so that you should be able to understand what I am actually saying. Now, will you be able to paint this graph with the minimum number of colors required? Can you find out the minimum number of colors required to paint this graph? Yes or
Yes,
no?
ma'am. Yes, ma'am.
How many of you did not understand what I have said? Please
Excuse
raise
me,
your
ma'am.
hand. I'm saying you this is a graph. There are different regions and you have to denote each region with the corresponding vertex. And then you will draw the edge between the two vertices. And then you have to find what are the minimum number of colors which are required to paint such kind of graph with having 6 vertices. V1, V2, V3, V4, V5, and V6. Is it clear? If clear, please raise your hands so that I can move further. You have
But
to
ma'am,
find, yes.
but in previous example, the minimum colors were already given, na?
Now they were
So,
given, but now you have to find. You can try with any color. Means you
so
can
ma'am,
try
we
with.
have to try manually. We have to check
Please
each
be
and every
louder. I'm
vertex.
not getting you, beta.
Ma'am, so we have to check each and every vertex
Yes, you have to
for
check.
that.
See suppose you just take an assumption from your side. Let us paint this graph with 3 colors. Fine. Then you see whether you'll be able to color these these
So
vertices.
ma'am, we have to initially take the three colors, na? Then we
Yes, you
have
have to
to.
assume that because for with two
Okay.
colors it won't be. ये तो common sense की बात है. You won't be able to paint such kind of graph with 2 colors. So minimum 3 colors तो आप लेके चलोगे. And if you will not be ending up in the solution, we will not be finding any solution. Then you will take the 4 colors. Fine.
Then increase the number. Okay, okay.
Hello.
Got it, ma'am.
Got it?
Got it, ma'am.
Got it?
Yes.
Everyone got it? Now please raise your hand if the things are clear. You have to assume what is the minimum number of colors that you'll be taking, assuming that the condition that no vertices, no directly connected vertices should have the same color. Fine. And then you will be painting these color of map. Fine. So इससे होगा क्या कि आप जब आपके पास कोई ऐसी प्रॉब्लम आती है, somebody says you find the minimum number of colors which are required to paint this graph. अब होगा कैसे, जो अर्लियर डेज में प्रॉब्लम होती थी, दैट वाज टू पास द पेपर नंबर ऑफ टाइम्स, नंबर ऑफ कलर्स वर यूज, फाइन। जैसे आपने 4 कलर यूज किए तो 4 बार पेपर जो है वो प्रिंटर में से निकलेगा। अगर आप 20 कलर्स यूज कर रहे हो तो 20 टाइम्स द कलर हैज टू बी, पेपर हैज टू बी पास टू द प्रिंटर इन ऑर्डर टू डिफरेंशिएट बिटवीन द रीजन। तो हुआ क्या कि ये जो उन्होंने बनाया कि मिनिमम नंबर ऑफ कलर्स जो रिक्वायर्ड है उसको चेक करने के लिए, इससे हमारा क्या होगा, M coloring optimization. We'll find M coloring optimization, that is the minimum number
ma'am.
of colors required to print this. Okay, is that clear now? It will give us the minimum number of colors which are required to print this graph, and it is called M coloring optimization. Is that clear
Ma'am,
now?
what would be the modern day
Excuse
example
me,
for
ma'am.
this?
Yes, yes, please ask.
Ma'am, why there is no edge between V3 and V4?
Why there is
No edge between V3 and V4.
V3 and V4? That is your assumption. You can take it. No problem.
Okay, yes,
You
ma'am.
can take it. Actually, what that is what I have done. You can even draw direct edge between V2 and V6 using V3. Since V3 was an edge, so I connected it to V5. You can connect it to V4 also. You can connect it to V1 also. That is your assumption.
Okay,
Okay?
yes, ma'am.
And ma'am,
Yes, ma'am.
Yes.
and ma'am, what would be the modern day example for this problem?
Yes.
For this solution?
What would be the
Modern day, ma'am,
modern day examples
example.
are, for example, जितने भी आपके maps बनते हैं, चाहे वो roads के बने, चाहे वो आपके networking के maps बनते हैं. See, you are having Wi-Fi at your places, fine. But उसके नीचे
Yes,
सारी
ma'am.
जो लाइन चलती है वो कौन सी चलती है? Fiber optics. राइट।
Yes.
तो वो नेटवर्क का शॉर्टेस्ट डिस्टेंस जो बनाना है, एंड यूजिंग दैट की अब हु नोज विच रोड इज बीइंग यूज्ड, जैसे अंडरग्राउंड वो होती है, वायर्स होती हैं, तो उधर फाइबर ऑप्टिक्स कौन सी कंपनी की पड़ी है, हमें कहाँ से पता चलेगा? वी विल गेट दिस फ्रॉम दिस मैप, पर्टिकुलर मैप। ओके, जो गैस की पाइपलाइन बिछती है वो भी ऐसी बिछती है। और मॉडर्न डे में जो भी आपकी मैप्स की कलरिंग होती है ना, फॉर एग्जांपल आपने इंडिया को डिफरेंट रीजन दिए हैं, बट वी सी सो मेनी कलर्स इन ग्राफ ऑफ इंडिया, ठीक है? तो आप उसको मिनिमम नंबर से रेंज कर सकते हैं। See, a particular person wants to find where are the coal reserves in India, so you can give this one color to it, petroleum to another color, इस तरह से आप different chemicals को different colors दे सकते हो मैप पे। आपने देखा होगा जितनी मैप बुक होती है उसमें डिफरेंट रीजन के लिए डिफरेंट कलर्स होते हैं। फॉर एग्जांपल यू हैव नॉर्दर्न रीजन जो होता है वो ग्रीन ग्रीन से शो किया जाता है, साउथ साइड पे थोड़े थोड़े पहाड़ दिखाए जाते हैं, वाटर एलिमेंट दिखाया जाता है। सो दैट इज डन विद द हेल्प ऑफ दिस ग्राफ। Okay. Hello. Am I able to answer you?
Yes,
Yes.
ma'am. Excuse me.
Okay.
Excuse me, ma'am.
Anyone else who want to know something so that we can proceed further?
Excuse me, ma'am.
Yes.
Ma'am, Manny is waiting outside, so please allow him to attend the lecture.
Yes. Mridul, do you have any question? You have raised your hand. Mridul, may I ask you what do you have the problem? Any problem you have?
No, ma'am.
Okay, from next time you should be joining at 9:30 only, because people are getting disconnected. They're coming again and again. I don't know why. Maybe there is some network issue. There's no problem. But try to join at 9:30 sharp. Many people have joined late today. Right? So next is your Dijkstra कहते हो, that you have done in your discrete mathematics cycle. But we will be now doing that particular problem. Yeah, now. Fine. So this graph coloring is over, and we will be moving to next part. I think this map, okay, fine. जिक्सा एग्जाम को बोलते हैं दिस कॉल्ड सिंगल सोर्स शॉर्टेस्ट पाथ एल्गोरिथम। ये आपका जब भी आपने कुछ नेटवर्किंग करनी है, रेलवे लाइंस बिछानी है, देन यू हैव टू इंट्रोड्यूस गैस पाइपलाइंस इन द सिटी, जस्ट लाइक जैसे अब हमने से इंट्रोड्यूस हो चुकी है। So this is done with the help of shortest path। कि fastest route उसको कौन सा मेरे आपके घर वाईफाई लगा है, तो वाईफाई के रीजन्स को पेंट करने के लिए we use that graph coloring method, लेकिन वाईफाई के रीजन्स बनाने के लिए we have to use this Dijkstra algorithm। तो इसमें हमने vertices दिए हैं, so this is a directed graph। Now what we have to do in this graph, we have to construct the shortest path using this vertices। Now it follows the greedy approach। It follows the greedy approach। Greedy approach क्या कहती है? You start with vertex 1, opt for the shortest path। That is, there are two edges which are going from two and the two edges which are going from one, that is one with weight 2, another is with weight 4 or cost 4। Fine, connecting edge 2 and 3. Now which we will opt for? 2. Then from 2 we will see which edges are outgoing. So accordingly we will be deciding that where we have to check. Fine. So the one difference is which is mentioned here. It is a directed, weighted directed graph. See, directions are given. So it is a weighted directed graph. We will update the value of dv of the final node. What is the distance which is covered by the final node with these formulas. Fine. Now how to implement it, I will just tell you. तो इसका मतलब when we are constructing the shortest path, that means we are finding the optimized value, that is minimum value for this path. So we are finding the optimized value. So it is also called, it is also used to solve the optimization problem. That is, we are finding the minimum value of your shortest path, that is minimum value of the entire graph. Fine, right from the, so इसके अंदर एक condition और भी होती है that you have to traverse each and every vertex at least once and with the minimum cost। You have to traverse each and every vertex at least once and you will be given that cost of the path which you will be traveling। Fine. So let's begin this problem. How to solve this? We're simply solving this problem। So initially सबसे पहला step आपने क्या करना है? You have to calculate the value from 1, put infinity on all the rest of vertices। Fine. Or you can make a matrix like here। Initial, there is no value at 1, so we will give it as 0, rest all as infinity, that I have done in the diagram also। Fine. So let's start off with the first edge, that edge is between 0 and 2। So you will mark the edges. First edge is between 0 and 2 and 0 and 3, sorry। First edge is between 0 and 2, second edge is between 0 and 3, या 1 to 2 ले लो, तब भी कोई दिक्कत नहीं है। So first edge is between 1 to 2 and second edge is between 1 to 6. Fine. So these are two directly connected edges. So let's do it। So what is the weight of 1 to 2? According to this formula, du, that is, if d of u is This is my starting index, which is indicated with U, and another is my ending index, which is your vertex 2. यहाँ पे मैंने लिखा है du is the starting vertex and dv is the ending vertex. So my starting vertex is 1 and ending vertex is 2. So I'm just putting these values here. So du plus d of u is d of 1 plus cost of u comma v, cost of 1 comma 2. 1 comma 2 the cost is 2. 1 comma 2 the cost is 2. So plus 2 is less than d of v. V is, that is 2. So if I put d of v, that is infinity. So 1 plus 2 is 0 and this is 2. So 2 is less than infinity. So which value we have to keep? We have to keep the smallest value. See, this is d table. D of 1 is, distance of 1 is 0. Distance of 2 is infinity. Distance of 3 is infinity, that I have taken. Fine. Now cost of u comma v, there is a weighted edge between 1 and 2 which is having the cost 2. So it is d of 1 plus 2 is less than infinity. See, d of v aana yahan pe. So it is d of v. So 0 plus 2 is less than infinity, 2 is less than infinity. That means smallest value which you can have on 2 is 2. So weight of node number 2 is now 2. So you will update it. Fine. Now let's do the third node. Second node is 1 to 3. 1 to 3. So I'll simply put here d of 3 is again infinity. Cost of u comma v, that is 1 comma 3 is 4. So 0 plus 4, 4 is less than infinity. So which value we have to keep? 4. So you will update this value as, are these two steps clear? If clear, please raise your hand so that I should move forward. Please raise your hand if these two steps are clear. Starting with the initial edge, you will mark first two edges 1 to 2 and 2 to 3. You have to find the weight of these two edges. D of, this is D table, distance of 1 is 0 because we are starting from the one node, that is initial node, it would be 0 only. Then D of 1 is 0 and cost of u comma v we have to take. Cost of u comma v, for the first case it is 2 because there is a direct connected edge, weighted connected edge between 1 and 2 which is having cost 2, and there is a direct edge between 1 and 3 having cost 4. So accordingly 4 is less than infinity, you have to keep the smallest value, that's why I have updated it to 2 and 4. So please raise your hand if these two steps are clear because I'm not looking many hands, only 3-4 hands are there. Nancy, Nazpreet, are you there? Rohit Kumar Singh, okay? Okay, fine. So next do the third edge now. Next edge is between, okay. Now from, see you are on vertex number 2 and vertex number 3. You have calculated the cost to reach the vertex 2 is 2 and cost to reach the vertex 3 is 3. Now which is the shortest one? दोनों में से smallest कौन सा है? सतगोवर सिंह, कोई क्वेश्चन है आपका? Is there any question? Okay, fine. So from 2 and 3, which is the smallest one now? कौन बताएगा मुझे? Anyone can tell me. Paras Kumawat, which is the smallest from 2 and 3? Please unmute yourself. I just want your participation. Anyone can unmute. Parth, are you there? Parth, Pawan, Prabjot Singh. Nobody is answering.
Ma'am, 2 node is closest.
Two node is having the smallest weight, so we will find the cost of the edges of 2 to 3 and 2 to 4. So let's find out the cost of the edge 2 to 3, that is 1, and 2 to 4, which is 7. Fine. So let's fill it in this formula. D of u is D of 2 plus C of u to 3. C of 2 to 3 is 1 and it should be less than D of v. D of v is D of 3. Now see, D of 3 is 4 because we have calculated, and C of 2 comma 3 is 1. So put 1 here, and D of 2 is what? 2. Now see, this is very important step. 2 plus 1 is 3 and 3 is less than 4. Now which is the smallest one? That is 3. So you will update the value of D of 3. This we have found D of 3. Fine. Because the edge last dv की value आ गई ना, dv is equal to du plus c of u comma v. So it is giving me d of v would be d of 3 is equal to d of u. D of u is what? 2 plus u comma v is 3. But we have value here as 4. So you are going to update it with 3. So this 4 is the, so you will update it with the 3. Fine. So I think if you are able to see, then it's okay. So you will update it with the 3. Fine. So next is 2 to 4. 2 to 4 is 7. D of 2 is 2 is less than D of 4, that is infinity. So 9 is less than infinity, true. So you can put 9 here. D of 4 is now 9. It is now 9. Fine. Now from next, see, now you have done this. Now second smallest from this 2, 3 and 9 is 2 you have done. This is now next move. From 3 to next edge is going towards 5. आपने next shortest लेना है, next smallest लेना है. So it is 3 to 5, which is having cost 3. So substitute in this 1. D of 3 is what? D of 3 is 3 plus C of u comma v. C of u comma v is 3, which is less than infinity. D of 5, which is less than infinity. So you will be updating this to what? 6. 6 is less than infinity. So you will substitute this formula. D of u is 3 and C of u is 3 and D of 5 will be equal to 6. Got it? Yes or no? If got it, please raise your hand. You have to upgrade the value here. Only 2 hands have been raised. Please be quick in responding. Okay, fine. So next, this is there. So हम इसको update कर देते हैं 6. Now 4 is having value 9, 5 is having value 6. Which is the smallest one? Who will tell me? Vishal. Yash है यहाँ पे. Vasu Malik. Vasu Malik, are you there?
Yes, ma'am.
Okay, now tell me which is the smallest one. From 4 or 5, from where we will start?
Ma'am, from 5.
Yes?
From 5.
From 5?
Yes, ma'am.
Okay, fine. So we'll start from 5. So how many edges are there from 5? Please apply, Vasu. From 5, one edge going toward 4. And what is the cost of it? This edge, I'll just check it. And from 5 to 6, it is
good.
5.
Yes.
I have raised it, I think. Just wait. It is 2. So it is 2. Okay. Now, let's do it. D of u is D of 5 plus C of u comma v is 2 is less than D of 4, and D of 4 is what? 9. So 6 plus 2, 8 is less than 9. 8 is less than 9. I think you are not able to see it, so I'll be doing this. 8 is less than 9. Now what we will do? See, 9 value is more than this while we are reaching it from some other way. So you will update this value to 8. So dv will be equal to du plus c of u comma v. See du की वैल्यू कितनी है आपकी 6. 6 plus 2 that is equal to 8. So d of v, that is d of 4, will be equal to this. So you will update this value to 8. Okay. Now from you will be calculating 5 comma 6. So let's do it. D of 5, c of u comma v is 5, and it should be less than d of 6, that is infinity. What is the value of d of 5? 6. So 6 plus 5 is less than infinity. Yes, it is true. So update this to 11. Update this to 11. Fine. So now you have found the shortest path from all the nodes. So let's draw the edges. See, now you have done this 11. Okay. Now next smallest is 4, because we have got 8 value. We cannot leave this question between. So let's do it from 4. From 4, it is only one edge, that is towards 6, and it is of what is the cost of this? 1. So this is 1. Okay. So let's do it. D of 4 plus c of u comma v is 1 is less than d of v, that is 11. So d of 4 is 8. 8 plus 1 is less than 11. So 9 is less than 11. So this would be 9 updated to 9. Okay, is it clear? Now let's draw the smallest part. ठीक है ये? Is it clear? Please reply. Raise your hands, please, if it is
Yes,
clear.
ma'am, clear.
Clear? Every step is clear, or you need to repeat something from it? You want to repeat something from it?
Clear,
Yes,
ma'am.
yes, Prince. What do you want to say? Simran, Shaurya Sharma, Shaman Jung, is this clear? I am not getting your hands. Smriti, Sarika, if it is clear, please raise your hand so that I should know how many of you have got it. Okay, now let's calculate the shortest distance path. So this would be my shortest distance. D of 1, weight of 1 would be 1, weight of 2, so this would be like this. 0, 0 to 2, then he will come here. I'll just do it. 0, 1 to 2, 2 to 3. So this is what my weight, this is 0, so this is 2, this is 3, 3 to 4. 3 to 4 is 8. Fine. So you will go via this 5. This way, I'll make it. D of 1 is 0, D2 is 2, D3 is 3, D4 is 8, and D5 is 6. 6 plus 2, 8, 8 plus 1, 9. ये रास्ता बनेगा. So this graph would be like this. Right? So D6 is equal to 9. So when you add up this, 3 plus 3 is 6, 6 plus 8 is 14, plus 6 is 20, 29 would be the answer. Okay. So what would be the answer for this graph? This would be 20. Just wait. No, okay. D1 is 0. Oh, I made a mistake. So 21 will be the shortest path. If I will be tracing this 1 to 2, 2 to 3, 3 to 5, 5 to 4, and 4 to 6. Am I audible? So let's do that with the negative cycles, and we'll see this extra is not applicable. It may be applicable or it may not be applicable for the negative edges. Right? So let's see how we will do it. I'm just making one diagram in front of you, and we will do that. Okay. See, if some graph like this is given to you, where the edges are having negative weight, Dijkstra algorithm is not able to provide us with the minimum value of this form. See, the total value will be deducted by -1, -6, or something like this. So they might end up in some loops. So in Dijkstra, we cannot find the solution to a graph when the negative weight edges are given. The solution to this is Bellman-Ford. So you can even, so this is your home task again. You have to draw the Dijkstra algorithm for this. Where you will tend to find to see where you are not able to find the negative, uh, sorry, that's minimum spanning tree for this negative edges. Fine. So you just try it at your home. I have given you the method how you can find it. The weights are given. The vector graph is there. Fine, and this is this way, 0 to 2. So the edges are 0 to 1, which is 5, 1 to 0, which is 0, and 2 to 0 is 2, or fine, sorry, 0 to 2. Then 3 to 0, it is -1, and 2 to 3, it is 6. Fine. So these 5 edges are given. UV I have given you, cost of U comma V I have given you. Now you can solve this using Dijkstra and tell me the right answer. Then I can tell you that how this algorithm fails, and then what is the solution to it is Bellman-Ford. This is again single source shortest path, but with negative edges. But with negative edges, right? So the formulas are different in this case. So you will be doing that. But before that, we will be doing the poll questions, and then we'll be again come back to do this method. Okay. So first of all, you should do the poll questions. So next is your Bellman-Ford algorithm. So I already told you. Can anyone brief what is to be done in this problem? You have to construct the shortest path algorithm by considering the negative weights of the edges. Fine. So this is the problem. And this is the graph which is given to me. 0 to 1, it is 5. I'll make it a little bigger so that you'll be able to see. And 0 to 1, it is 3. 1 to 3, it is 4. -1, 2, and 6. Fine. So this is the connected graph which is given to me, and I have written the edges and the corresponding weights. Here you have to make the two matrices. One is for distance that you have done in the previous section, and P is the predecessor. मतलब parent कौन है V का, उसके लिए आपको एक मैट्रिक्स बनाना पड़ेगा. Parent of 0 जो भी होगा, 1 क्या है, 2 क्या है, 3 क्या है, since we are having only 4 vertices in this graph. Fine. Okay, so you have to find the parent, and because in the end आपको ये connect करके बताना होगा कि कौन सा edge किससे related है, so that's why P will come to the play. Now the formula, again that formula is there. Relax an edge. Relaxing क्या होती है? What is the relaxing of an edge? That I will tell you. formula is if v of d is greater than u of d plus weight of u comma v, u is your starting index and the starting vertex and v is your destination vertex. Fine, u is source vertex and v is your destination vertex. So v w u comma v, if this is greater, that means there is a better path which is there, and so you can update the value of vd by moving the large value with the small value, and the v of parent will be v of t will be u. Fine, v का parent जो होगा वो क्या बन जाएगा u. So I've written u dot d is start vertex, v of d is ending vertex, w comma v is weight of edge u comma v, and vp is the predecessor of that vertex v. Okay, that is predecessor of vertex v. Now अब इसमें होगा क्या, जितने vertex होते हैं ना, suppose there are 4 vertices, so you have to iterate n minus 1 times. Iterate for n minus 1 times. Okay, उसके बाद last iteration जो होती है, last iteration is used to detect the negative cycle in the graph. Last iteration in this Bellman-Ford algorithm is used to detect the negative cycle in the graph. Negative cycle means अगर last iteration के बाद अभी भी negative cycle होता है, values change हो रही हैं, that means we cannot calculate the value of the graph, but it can tell that there is a negative cycle. That's why we are not able to calculate the value. Fine. So this is what Bellman-Ford says. मीन्स आपको अगर 4 दिए हैं तो 3 आइट्रेशन हम करेंगे, 3 आइट्रेशन के बाद हम देखते हैं वैल्यूज में चेंज आ रहा है कि नहीं आ रहा. विल टेक बोथ द केसेस वेयर द वैल्यूज आर चेंजिंग एंड वेयर द वैल्यूज आर नॉट चेंजिंग. सो आई थिंक वन केस विल बी डन टुडे, अनदर केस विल बी डन day after, whenever next Monday will come. So we will do on that day, and we will compare how the iterations are performed and how to detect the negative cycle and where the negative this Bellman-Ford algorithm fails. So I'll tell you, because Dijkstra algorithm fails for the negative edges and Bellman algorithm where it would fail, we'll see. Right? So let's start with iteration 1. First of all, we will write here iteration 1. Right? So this is the iteration 1. First of all, put that formula. What is the formula which we have written? Relaxing of an edge is nothing but updating the value of this distance matrix with a better value. Means अगर आपके पास 9 है and you found the value 8, so 8 is a better value than 9, so you will update. That is called relaxing of edge. तो यहाँ पे लिखेंगे relax edge u comma v if v of d is greater than u of v plus c of u comma v, or weight of c or v is one and the same thing, then v dot d will be equal to u dot v plus w of u comma v, and v of p is equal to u. You just write this formula, and for every edge we will be taking. So we'll start from here 0 to 1. So u is 0, v is 1. Initially, you have to start from the 0 index and the weight will be 0. All other will have infinity. So put this formula v dot d. v की वैल्यू कितनी है 1. So 1 dot d is greater, check करना आपने, is 1 dot d is greater than u dot v u dot v is 0 dot d plus weight of u comma v. So u comma v का weight कितना है 5. So 5 plus 0, infinity is greater than 0 plus 5. Yes, condition is true. So put the better value, that is 5. So vd is what? 1 comma d is equal to u comma d, u dot d is 2 and weight is 5. So 1 dot d की वैल्यू कितनी हो जाएगी यहाँ पे 5. Now v dot p is equal to u. 1 dot p, 1 का predecessor p क्या होएगा 0. So you will put 0 here. Fine, you will put 0 here, and 0 का predecessor कोई नहीं है, so you just put blank here. Fine, so इस तरह से आपकी calculate होगी. Is this clear? If it is clear, please raise your hands so that I can go to next iteration. Okay, next. So next edges, what? 0 to 2. 0 is 0 and B is 2 and the cost is 2. W of U comma P is 2. So put this value. I'll simply put this value. 2 dot D is greater than U dot D, 0 dot D plus weight is 2. So 2 dot D is, what is the value? Infinity. Infinity is greater than 0 plus 2, that is 2. So put the better value here. So put better value, that is 2 here, and V of P, that is 2 dot P is U, that is again 0. So put 0 here. Fine. 2 dot P is again 0. So put that. Just remember this formula and you have to put all the things there. Is this clear? Please raise your hand. Be quick because we will complete one iteration only. Okay, fine. So let's take the third edge. U, V, and this is this. U is 1, V is 3, and weight of U comma V is 4. So put 3D is greater than, check 1 dot D plus 4. So it is 1 dot D is what now? 1 dot D is 5. 5 plus 4. 3 dot D is infinity. So infinity is greater than 9. So update this value with the 9. And V dot P is equal to U. That is 3 dot D is equal to 1. So put 1. 3 dot D will be, V की value कितनी है? 3. So 3 dot P is equal to U. U की value कितनी है आपके पास? 1. So put 1 here. Is it clear? Please raise your hand. If it is clear, please raise your hand. You have to substitute this thing here, okay, fine? So let's do next iteration part. U is equal to 2, V is equal to 3, and weight of U comma V is 6. Am I doing it right? Anyone can unmute. We were on the iteration, the third part na. 2, 2, 3 करना है ना हमें. Okay. 3 dot D is greater than 2 dot D plus 6. 2 dot D की वैल्यू कितनी है? 2 plus 6. 3 dot D की वैल्यू कितनी है? 9. 9 is greater than 8. Condition क्या है? True. So change this value to 8. And now V of P, that is 3 dot P is equal to U, which is equal to 2. So update it to 2. Update it to 2. 3 dot P is equal to U and U is equal to 2. Okay. So this is your third iteration. Now 3 to 0. U is equal to 3. V is equal to 0 and weight of U comma V is what? -1. This is very, very important now. So V dot D, 0 dot D is greater than 3 dot D minus 1. So 0 dot D is 0. 0 is greater than 3 dot D. 3 dot D is 8. Minus 1, 7. 0 is 7, greater than 7. So condition क्या आपकी false. Now move to next iteration because we have completed first iteration part. We have completed first iteration. False का मतलब होता है move to next step. No, you have not to make any changes. Move to next iteration. No changes is to be done. Are you clear with the first iteration? Please raise your hand because we are just having 10 minutes to go and I have to complete this question in the 10 minutes. Okay, fine. Now again start off with this. U is equal to 1, 0. First आप कंसिडर करेंगे एज 0 to 1 वाला. सेकेंड आइट्रेशन शुरू हो गया है. यहाँ आप लिखेंगे आइट्रेशन 2. So V is equal to 1. W of U comma V is 5. Now see, V of D is 1 comma D is greater than 0 comma D plus 5. 0 comma D is 1 comma d is 5. 0 plus 5. 5 is greater than 5. False. Move to next iteration, next part. False में आपने कोई changes नहीं करनी. You have not to make any changes in D and P. So let's go to next. 0 to 2. So U0, V2, and here we have 2. Okay. So let's do it. 2 dot D is greater than 0 dot D plus 2. 0 dot D is 2. So 2 is greater than equal to 2. Condition क्या है? False. 2 can never be greater than 2. So we have to move to next part. Okay, we have to move to the next part. So let's take U as 1, V as 3, and weight is 4. So let's do it. Check 3 comma D is greater than 1 dot D plus 4. 1 dot D is 5 plus 4, 3 dot D is 8. 8 is not greater than 9. 8 is not greater than 9. So move to next edge. Move to next edge because condition is false. Because the condition is false, so you will moving to next edge. Till यहाँ तक किसी को कोई problem है तो you can ask your questions. If it is clear, then raise your hands, please. Be quick in raising hands so that you should not take much more time in raising the hands. Okay, fine. So move to next edge. 2 comma 3. It is going to be 6. So V dot D is 3 dot D is greater than 2 dot D plus 6. 2 dot D is 2 plus 6. So 8 is greater than 8. Condition क्या है? False. No changes are to be done. Here it is there. Okay. And then again move to next edge. D is equal to U is equal to 3. D is equal to 0. And this is minus 1. So 0 dot D is greater than 3 dot D plus minus 1. 3 dot D is 8. 8 minus 1, it will be 7. 0 is greater than 7. No. So condition is again false. Now move to next iteration. You have to check the values in every iteration. Fine. तो अभी तक यहाँ पे कोई अपडेशन नहीं हुई है तो इसलिए हमें आइटरेशन 3 करने की जरूरत नहीं है बिकॉज वी आर नॉट गोइंग टू चेंज एनी वैल्यूज देयर ओके तो हमारे पास अब जब लास्ट में आइटरेशन 3 हो गई है खत्म आइटरेशन 3 में भी यही सब कुछ होगा सिंस वी आर नॉट मेकिंग एनी चेंजेस टू द वैल्यू सो ये हमारे पास नहीं आएगी अब आइटरेशन 4 में क्या होता है मैंने आपको बताया यू हैव टू आइटरेट n minus 1 times and last iteration is done to detect the negative cycle. See, if there is any change in iteration 4 in D and P matrix, fine. If there is any change in iteration 4 in D and P matrix, then there is a negative cycle and we cannot draw the minimum spanning tree or minimum weighted graph for this whole graph. And but if there is no change in both the cycles, both the matrices, that is D and P, then we can make the graph. Now see, let's see how we will be making that. In iteration 4, you will be not getting any change. So you can make the graph. How you will make the graph is shortest distance 0 to 0 it is 0 from 1 to 0 it is 5 shortest distance from 1 to 0 it is 5 from 2 to 0 it is see you have to check this and this is your final vertex from 2 to 0 it is 2 and from 3 to 0 it is 8 3 to 0 it is 8 now how to use this fine we will do this way 0 to 1 it is 5 then 1 to 2 it is 2, and from 0 to 3 it is 8. So it is via 3. See, we have done this. 0 to 1 it is 2, 0 to 2 it is ulta likh lijiye aap. That would be better for you to understand. 0 to 3 it would be 8 and this way. Fine. So this is how you will be doing 5, 2 and 6 total weighted graph will be 5, 2, 7, 8, 15. Okay. So this would be your answer. Do you want me to do iteration 4? If yes, please raise your hands. Do you want me to do iteration 4 since there will be no changes in iteration 4 also? If you want me to do iteration 4, I can do it right now because we are left with 5 minutes and we can do easily. Answer is complete now. Or you can do it by yourself. If yes, then you can tell me also.